understood whatever part we have seen in last lecture, that is regarding with the CRC? Everyone has understood it, or should I repeat it again?
मैम
Shall I
रिपीट
get it?
करा
Sir?
रिपीट
Sorry.
करा मैम रिपीट करा
What? Don't know. Okay, I will repeat it again within 5 or 10 minutes. Please pay attention because it is important concept as I already told. Most of the time it is asked also in gate questions also. The questions are related with the CRC they have given. So please pay attention how to solve the examples related with the CRC. Okay, so CRC, it is nothing but the cyclic redundancy check. It is one of the method for error detection. Okay, error detection means at the receiver side whether receiver has got the proper message which is sent by the sender or not, to check that CRC is used. So we can say that CRC is only an error detection. It will not correct an error. ओके. सो सीआरसी काय करतो, फक्त रिसिव्हर साईडला मेसेज गेलाय का नाही हे चेक करतो. सीआरसी जो मेसेज गेलेला आहे तो जर रॉंग असेल तर तो करेक्ट करायचं काम करत नाही. इट ओनली चेक्स वेदर मेसेज or whether the received message contains any error or not. That is only conclusion. Then how it is being checked, so we perform some operations on sender as well as the receiver side, and if the receiver side the reminder is not zero, it means that there is an error and the receiver doesn't accept it. जर रिमाइंडरला नॉन झिरो व्हॅल्यू आलेली असेल तर रिसिव्हर काय करतो, कन्क्लूड करतो की देर इज एन एरर and it doesn't accept it. And if the reminder is all zeros, then there is no error and it accepts it. So that is the best conclusion which we need to consider related with the CRC. Okay, that we have to keep in mind. Also regarding the CRC, we are performing the XOR operation. XOR operation is what? If the values are same, then the value is 0 or answer is 0, and if the values are different, then value answer is 1. That is the second assumption. And the third one is that we have to add some extra bits in given data or given frame. Okay, and these bits we can say that these can be a checksum or parity bits, whatever. Okay, and these checksums or the parity bits we are adding depending upon the size of the generator. जनरेटर म्हणजे काय असतो, ज्यांना आपण भागतो तो जनरेटर असतो. ठीक आहे, मग जनरेटरची साईज जी असेल त्याच्या -1 आपण चेक बिट्स ऍड करत असतो. Okay, so these check bits are added at the sender as well as receiver side. Only difference is what? At the sender side we are adding zeros, and at the receiver side we are adding CRC. Okay, so I'll directly move to one example because already all this part we have seen. Okay, so I'll explain this example quickly. Just see here. So this is the data given 1101 011 011. Okay, this data is given and this generator is given x raised to 4 plus x plus 1. Okay, that is the data given. Now what we have to calculate the remainder using CRC. Okay, means CRC method we have to apply. So x raised to 4 plus x plus 1, from here we are getting this generator. Okay, how? That is explanation also we have checked. So this is how many bit data is there. Generator चे bits किती आहेत? 5 digits आहेत. So 4 zeros append करायचे. Okay, so 4 zeros are appended at the sender side. So माझी जी frame आहे त्याला मी काय केलं, 4 zeros add केले. As the size is 5, we have added 4 zeros. ठीक आहे, so this is the first step we have to consider. Then next नंतर काय करायचंय की we have to consider whole frame including all zeros, whatever data we are getting here. So that we have to consider as a whole data, including zeros, and we have to perform operation by using the generator. Okay, now generator is what? 100011, and this is our data. Here we have to perform exclusive OR operation. So as I told you, exclusive OR, सेम बिट्स असतील तर 0 आन्सर येतं, डिफरंट बिट असेल तर 1 आन्सर येतं. ओके, नाउ सी हियर. सो हाऊ मेनी बिट्स आर देयर? 5 बिट्स आहेत याचे. सो कन्सिडर द फर्स्ट 5 बिट्स ऑफ युअर डेटा आणि त्यालाच भागायचं. ओके, 5 बिट्स up to this. What is the first bit? It is 1. Okay, so this should be, or your what we can exponential. Okay, this is, it is again 1. So 1 into 10011, value is 10011. Now on these two, perform the XOR operation. Okay, so XOR operation, 0 1, different values at 1 आलं, 1 1 0 0 0 0 0 1 0 1 1 1 0. Now the next stage, next काय आहे? Next we have to consider these values. So I have taken this here 1, and as we are taking this, discard the first bit because our generator is of 5 bits. So 10011 will be the next value. Again check the first bit, it is 1. So again multiply by 1. 1 into 10011. So this is 1. Again this value will come. Again consider the next bit. Discard the first bit. Similar process we have to obtain, and it is my sender side. So whatever reminder I am getting, that will be my CRC. Okay, so in this case I am getting the CRC as a 1110. That is my CRC or the reminder. Now at the receiver side also we have to follow the same procedure. Only difference is that we have to discard these 4 zeros and we have to add this 4-bit CRC over here. So the frame will be same. Instead of these 4 zeros, values will be 1110, and again the same procedure I have to follow. Okay, so at the receiver side, after solving this example, if I get all these zeros, it means that there is no error. User, whatever data sent by the sender is exactly received by the receiver. So that will be the my conclusion. In exam, if you are solving this example, and if the question is like just apply the CRC, and suppose you are not getting any zero value at the receiver side, it means that you have missed something, your answer is wrong. रिसिव्हर साईडला तुम्हाला CRC आला नाही एक्झाम मध्ये, तर समजायचं की आपला आन्सर चुकलेलं आहे. ठीक आहे, आणि जर सपोज क्वेश्चन आलेलं असेल की कन्सिडर एरर, कुठल्या तरी एका एरर चेक करायचं असेल, देन इट इज ओके, आन्सर विल नॉट कम ॲज अ 1. So that will be the procedure for the CRC. Unless and until you solve the example or you try some examples at home, you will not understood. Okay, so you have to solve the examples, then only it will be understood, otherwise no. जोपर्यंत प्रॅक्टिस करत नाही तोपर्यंत येणार नाही. And on this same CRC we have to perform, or we have to generate one program also. We have to check what is the CRC. So remember, you have to understood this procedure. There is an one experiment on CRC also. Okay, so let's move to the next part. Is there any problem still?
No, ma'am.
No, everyone has understood ना? जोपर्यंत मी आज तुम्हाला एक PDF पाठवते, or some examples I will give you today. You please solve it, practice it, so that you will get understood. ठीक है? So
Yes, ma'am.
this example so we have seen in last lecture. This much part we have covered. Okay, so next part, it is again one of the algorithm. It is quite difficult, but uh, remember the steps. So after that, I think there will not be any issue. So see, we'll see Hamming code. So as like CRC, Hamming code is also error detecting as well as correcting method. What is the difference in CRC and Hamming code is that CRC is used only for detection of error at the receiver side. CRC का use क्या होता है error आहे का नाही हे detect करणं. But exactly reverse, Hamming code is used for detection as well as correction of the error. If any bit error is there, एखादा bit जर change झालेला असेल, then we can correct that error. So that is the use of the Hamming code method. Okay, so what is this algorithm? We will see. So I have some PDF. Is it visible, na?
Yes, ma'am.
Yes, ma'am.
Yes, yes. Okay. So, as I told you, Hamming code, it is an error detecting as well as correcting method. ठीक आहे. डिफरन्स लक्षात ठेवायचं. सीआरसी मधून काय होत होतं, फक्त आपण रिसिव्हर साईडला एरर आहे का नाही हे फक्त डिटेक्ट करू शकत होतो. असली एरर तर काय करू शकतोय का? नो. बट विथ द हेल्प ऑफ द हॅमिंग कोड वी कॅन correct also. If there is an error, then we can correct that error also. Okay. So what's Hamming code? Normally frame consists of bit or m data bits, and these are redundant or check bits. Okay. So total length is equals to n is equals to m plus r. What is the meaning of this is that Hamming code contains the data which includes data or your frame as well as some extra check bits as like CRC. CRC मध्ये आपण एक्स्ट्रा चेक बिट्स काय ऍड करत होतो? झिरोज ऍड करत होतो सेंडरला आणि रिसिव्हरला सीआरसी ऍड करत होतो. सिमिलरली इन केस ऑफ द हॅमिंग कोड, इफ सपोज my data is of m bit, okay, in that I have to add some extra bits which are called as the parity bits. ठीक है. So what is the use of these parity bits? These are used to check the errors, whether the data contains any error or not. That for that these extra bits are added to check the errors, and these bits are called as the parity bits. So my data length will be m plus r. M means original data or original frame plus extra parity bits that I should add over here. So that will be my length of the data. Okay. Now the n bit unit containing data and check bit is often referred to as a n bit code word. So पूरी data once I include the parity bits in my original data, the whole frame is called as a code word. Okay. Suppose माझा data आहे 1011. Okay. In that, suppose I have added some 3 extra parity bits 111. So this whole frame, my original frame plus parity bits, whole data is called as a code word. Remember, this is asked for the MCQs. Each and everything you should understood over here. Because Hamming code जर question आला तर 10 marks fix. 10 marks ला असतो हा question. So pay attention. Okay. So total length काय आली? तुमची frame plus parity bits. Parity bits are what? These are the extra bits which are added in your original data.
Hello,
Why
ma'am.
these are added? Yes.
Hello, ma'am. Your voice is breaking. Voice is breaking. Your.
Yes, ma'am, your voice is
Actually, I'm
breaking.
having the full network. Okay, I have best network issue तर काही नाहीये. I don't know what is the problem. Okay, so let it be. I'll start. Okay. Mhm. So what is the parity bits, these are added to check whether your data contains any error or not. So to check that, parity bits are added. Okay. Now next is what? Whole this is called as a code word. Okay. So let's example. One example is given over here. Let's consider two code words. Means what? These are the two data: 100, 1000, 1001, 1011, okay, this is one example of the code word. So this will include parity bits plus your data or your frame. Next, it is possible to determine how many corresponding bits differ. Okay, means what? Suppose these are the two code words which I am getting, one at a sender side and one at a receiver side. Now, from these two code words or two frames, I can understand how many bits are differed or how many bits are wrong. ठीक आहे. आता हे काय दोन आहेत, सेंडरला एक आणि रिसिव्हर साईडला हा एक डेटा आहे सपोज फॉर एक्झाम्पल. नाव ह्या दोघांच्या वरून मला हे कळू शकतं की ह्या दोघांच्या मधले किती बिट्स चुकीचे झालेले आहेत. ठीक आहे. आता हाऊ इट इज अंडरस्टूड? सो फॉर दिस इट uses the XOR operation. Okay, for this it uses XOR operation, and whatever answer I will get, that is considered as a Hamming distance. Remember the definition, huh? Whatever answer I am getting from these two two code words after applying the XOR operation, then that is called as a Hamming distance. Now, how this Hamming distance is calculated? See here. Yeah, for example, this one. Okay, so suppose 000 is one code word and 011 is second code word. On this, I have performed XOR operation. So what is the XOR 011 How many ones are here? These are the two ones are here. Okay, so whatever number of ones are available, that will be considered as my Hamming distance. It means that in these two code words, two bits are different or these two bits are changed. Now कुठले बिट्स चेंज झालेले आहेत ते करेक्ट कसे करायचे, दॅट इज द अनदर पार्ट. तो पुन्हा पुढे अल्गोरिदम आहे. Okay, so what is the Hamming distance? It is 2 because two ones are present over here. That is the Hamming distance. Okay, similarly, again the another example. Suppose these are the two code words. So 101, then 011, 110, 011, 110. How many ones are there? 3 ones are there. So what is the Hamming distance? It is 3. Because 3 ones are present in the answer. So Hamming distance is 3. Okay, so what is the definition of Hamming distance? It is a distance between two code words or two words, is the number of differences between the corresponding bits. And how to calculate these differences? By using XOR operation. Okay, up up to now, anybody is having any problem? इथपर्यंत समजले जे सांगितले ते what is Hamming code and how to calculate the Hamming distance. Anybody is having any problem?
No, ma'am.
Everyone has understood this Hamming code? I should
Yes,
ask.
ma'am.
But yes. Okay, Pawan,
Yes, ma'am. Understood.
understood. Okay. Vijay, Nikam. Vijay, don't know. Huh? Ganesh, Ganesh? Yes, I got the message, Umraj. Okay. Pranav. Pranav Dongre. Have you understood? Yes. Omkar. Yes. Okay. Having code repeat kara. Okay. Okay. So I'll repeat once again. Please pay attention. Okay. Hamming code is what? It is one of the algorithm or one of the method which is used for detection as well as correction of the error. Okay. So how to detect and correct? So the algorithm is different. Now before that, first consider that in the Hamming code. One second. Okay, so Hamming code size of the frame is what it checks or uh, it adds some extra bits as a parity bits or check bits in your original data. Okay, and these check bits are used to check the error. Okay, now total size after adding these check bits in your original data will be the total frame. Okay, so Hamming code is method which is used for error detection as well as correction. It adds some extra bits which are called as a parity bits or check bits, and the total frame will be original data plus your check bits or the parity bits. Now there is one more concept, and the whole data is called as a code word. Now with the help of these code words, I can check how many bits are actually differ at the receiver side in two code words. Suppose these are the two frames I'm getting after applying the algorithm. So on this, suppose I have performed the XOR operation, whatever answer I will get, so that will be my Hamming distance. And from that Hamming distance, I can conclude that these many bits are differ in these two code words. So suppose answer is 011. So number of ones are 2. It means that 2 bits are different or these are changed at the receiver side. Okay. So that is the consideration for the Hamming code, and it is called as a Hamming distance. And generally it is represented as a D of XY. Okay. Now next after this, what is the Hamming code? So definition is it is an error detection and correction mechanism that can be used to detect as well as correct bit errors that can occur when data is stored or transmitted. So that is the definition. Now what is mean by the parity bits or we can say check bits? मी मगाशी सांगितलं की ओरिजिनल डेटा मध्ये तुम्हाला एक्स्ट्रा चेक बिट्स किंवा पॅरिटी बिट्स ऍड केले जातात. नाउ व्हॉट इज दिस पॅरिटी बिट? So Hamming code uses concept of a parity bits, which are the bits that are added to data so that the validity of data can be checked when it is moved or it is received in the transmission. Okay. What is the purpose of the parity bit? So these are added to check validity. Validity means what? Whether your data is correct or not. So the to check this, these parity bits or extra bits are added. ठीक आहे. सो पॅरिटी बिट्स आर इन्सर्टेड इन बिटवीन द डेटा बिट्स. आता हे कुठे ऍड करायचे, आपण सीआरसी मध्ये कसे ऍड करत होतो, वी आर ऍडिंग द बिट्स ऍट द एंड ऑफ द डेटा. झिरो कुठे ऍड होत होते, डेटाच्या शेवटी ऍड करत होतो. बट इन केस ऑफ द हॅमिंग कोड वी हॅव टू ऍड दिस पॅरिटी बिट्स इन बिटवीन द डेटा. Okay, but how to add this parity bits? So for that we have to consider this Hamming code structure. ठीक है, Hamming code structure is what? So whatever data we have given, जो काय डेटा दिलेला असेल, फ्रॉम दॅट वी हॅव टू ऍड द एक्स्ट्रा पॅरिटी बिट्स. आता हे पॅरिटी बिट्स कोण ऍड करणार आणि कुठे ऍड करणार, तर आपण स्वतः तिथं ऍड करायचे. आता कसे ऍड करायचे, आय शो यू. ओके, सो all bit position that are powers of 2 are marked as a parity bit and other bit positions are marked as a data bits. ठीक आहे, मीन्स व्हॉट, सपोज जर माझा डेटा आहे 8 बिट्सचा आहे, टोटल 8 बिट्स आहेत, तर त्या 8 बिट मधले जेवढे काही 2चे पॉवरचे पोझिशन असतील त्या सगळे काय असतील, माझे पॅरिटी बिट्स असतील आणि राहिलेला सगळा काय असेल, माझा डेटा असेल. ओके, फॉर एक्झाम्पल आता proves 2 power 0 is what, 1. So first bit is my parity bit. Then 2 power 1 is what, 2. So second one is the parity bit. Now 2 power 2 is what, 4. So fourth bit will be parity bit. Similarly 2 power 3, 8. Eighth bit will be parity bit and so on. And remaining all will be the data bits. Okay, I hope यू आर गेटिंग इट. थोडस जरी समजत असेल तरी इट इज ओके. मी अजून हे कमीत कमी 2 वेळा रिपीट करणार आहे. हे बाय हार्टच झालं तरच लक्षात येईल, अदरवाईज नाही. ह्या स्टेप्स सगळ्या लक्षात आल्याच पाहिजेत, त्यामुळे मी अजून 2 वेळा रिपीट करणार आहे. पण इनिशियली थोडं जरी लक्षात आलं तरी आय एम हॅपी. ठीक आहे, सो पे अटेन्शन. व्हॉट एव्हर पॅरिटी बिट्स ऍड करायच्या आहेत आपल्याला, त्या ऍड करताना काय करायचे, तर डेटाचे जे पोझिशन्स आहेत त्या लक्षात घ्यायच्या अँड अकॉर्डिंगली पॅरिटी बिट्स ऍड करत जायचं. मग पोझिशन्स कशा असणार आहेत, तर व्हॉट एव्हर पोझिशन दॅट आर पॉवर्स ऑफ 2 आर मार्क्ड ॲज अ पॅरिटी बिट. 2च्या पॉवर मधले जे पोझिशन्स असतील ते सगळे काय असतील, माझे पॅरिटी बिट्स असतील अँड रिमेनिंग ऑल आर द डेटा बिट्स. ठीक आहे, सो दिस इज द फॉर्मेशन ऑफ द हॅमिंग कोड. हॅमिंग कोड जनरेट कसा करायचा ते सांग, बिकॉज in exam might be they have given only data, might be they have given hemming code, full structure पण दिलेला असेल किंवा डेटा पण दिलेला असेल, whatever. If data is given we have to add the parity bits, only parity bits we have to add. If suppose whole hemming code is given, no need to add the parity bits. ठीक है, so similarly suppose if my data is 15 bit hemming code is there, now what will be the parity bits? So p1 is the parity, p2 is parity, p4 is parity, then p8 is parity and remaining all will be the data bits. Simple, remember this. ठीक आहे, नाव हे काय झालं, इथपर्यंत झालं फक्त तुमचं स्ट्रक्चर कसं असतं. But as these as these parity bits we are adding, these are the extra bits, we have to calculate this extra bit na. Randomly I can't add 0 1 1 1, no, I can't add it. There must be some strategy to calculate these bits, am I correct? So that is nothing but the parity calculation, the second part. Okay, let's see what is this parity calculation, how the parity is actually calculated. Okay, see here how to calculate the parity values. So Suppose this is the data, huh? P1, P2, D3, P4, D5, D6, and D7. Up to this, parity bits are what? P1, P2, and P4. So 3 bits we have to calculate. 3 bits याच्यामध्ये काढायचे. Remaining 4 will be given. दिलेले असेल डेटा. याच्यामध्ये बिट्स आपल्याला कुठले कुठले काढायचे, कॅल्क्युलेट कुठले कुठले करायचे, P1, P2 आणि P4. These three. Now, how to calculate this one? For example, this is the data and I have to calculate P1. मला काय करायचं, P1 calculate करायचं. So in that case, what I should consider here is that check one bit, skip one bit. ही strategy follow करायची in case of the P1. So P1 ला काय असेल, चेक कुठला करणार मी, P1 skip P2, then check D3 skip P4, check D5 skip D6, check D7. चेक मीन्स व्हॉट, हे सगळे कन्सिडर करायचे आणि स्किप म्हणजे काय, स्किप करायचे. सिमिलरली P2 आहे, फॉर एक्झाम्पल मला P2 ची व्हॅल्यू काढायची, तर काय करायचं, चेक 2 bit skip 2 bit. ओके, चेक 2 bit skip 2 bit. सेम प्रोसिजर फॉलो करत जायचं, बट स्टार्ट फ्रॉम P2 इटसेल्फ, नॉट फ्रॉम द P1. सो चेक कुठले कुठले येणार, P2 D3 चेक करायचे, P4 D5 स्किप करायचा, D6 D7 चेक करायचे, अँड सो ऑन. ओके, नाव सपोज मला P4 ची व्हॅल्यू काढायची. हाऊ कॅन आय कॅल्क्युलेट द P4? येस, एनीबडी? सपोज जर मला P4 ची व्हॅल्यू काढायची असेल तर मी कुठले बिट कन्सिडर करणार?
P2, P4, D6.
नो नो नो, P4 ची काढायची व्हॅल्यू, P4. इफ सपोज P4 ची व्हॅल्यू काढायची असेल तर 4 बिट्स चेक करायचे, 4 स्किप करायचे, बट स्टार्ट फ्रॉम P4 ओनली. हा, सो चेक कुठले करणार मी, P4 D5 D6 अँड D7. These bits I have to check. ठीक आहे, समजलं इथपर्यंत? हे सगळं थोडंसं अज्युम करायचं आहे, एक्झाम्पल मध्ये तुम्हाला एक्झॅक्ट लक्षात येईल. फक्त तिथं मी पुन्हा म्हणणार हे स्किप करायचं, हे कन्सिडर करायचं, पण का, ह्याचं मी एक्सप्लेनेशन इथं तुम्हाला दिलं. ठीक आहे, येस और नो? येस, समजतंय ना, समजलं नाही इथपर्यंत?
Yes, ma'am.
समजले. ओके, नाव एक आता छोटं एक एक्झाम्पल दाखवते तुम्हाला, सो दॅट फ्रॉम दॅट यू विल अंडरस्टूड अप टू दिस. इथपर्यंत आता व्हॉट एव्हर मी सांगितलेलं आहे, जे काही थेरी बडबडली, ते ऍक्च्युअल मध्ये कसं दिसणार आहे आणि कसे पॅरिटी बिट्स निघतील, दॅट वी विल सी नाव. ओके, दिस इज द हाफ पार्ट ओनली. हा, सो विल सी वन एक्झाम्पल ओव्हर हिअर. आय शो यू वन एक्झाम्पल. Yeah, this one. Okay, don't read the example because we have to solve it again. Suppose this is my total Hamming code. ठीक आहे, नको हे नकोच एक्झाम्पल आपल्याला. This example we will see. Now suppose the data given is 1010. हा डेटा आहे. Okay, you can see the example. So 1010, that is the only data given. Okay, from that we have to construct the Hamming code as well as we have to detect and correct the error. So आता फक्त आपण काय करणार आहे की हॅमिंग कोड कसा कन्स्ट्रक्ट करायचा आणि त्याचे पॅरिटी बिट्स कॅल्क्युलेट कसे करायचे हे फक्त आता बघणार आहेत ह्या इथं. तर 1010 is the 4-bit data. Okay, so we have to add the extra parity bits over here. Now one more thing I forget, how many parity bits should be there? या दिस इज गिवन ओव्हर हिअर. एक्झॅक्टली किती पॅरिटी बिट्स मी ऍड करायला पाहिजेत माझ्या डेटामध्ये, दॅट शुड बी ऑल्सो कॅल्क्युलेटेड. सो द व्हॅल्यू ऑफ द पॅरिटी बिट शुड बी 2 raised to p greater than or equals to n plus p plus 1. So that is the formula. Okay, n is nothing but the data bits. So माझ्या पॅरिटी बिट्स किती असले पाहिजेत, सो त्याची व्हॅल्यू कशी असेल माझी, डेटा बिट्स प्लस पॅरिटी बिट्स प्लस 1. ओके, सो जनरली एक्झाम मध्ये मोस्टली 8 बिट पर्यंतच तुम्हाला डेटा येतो. सो मोस्टली वी हॅव टू कॅल्क्युलेट ओनली 3 पॅरिटी बिट्स इन एक्झाम. Okay, so if 4 bit data is given, then mostly 3 parity bits are there. Okay, now let's see how to calculate these parity bits. So structure काय झाला, so as I told you 2 चे पॉवरच्या सगळ्या पोझिशन्स काय असणार आहे, that will be considered as a parity bits. So you can see here p1 is blank, p2 is blank, d3 is given here 0. Okay, then p4 is blank, d5 is this 1, then d6 is 0 and d7 is 1. So that will be my Hamming code or Hamming structure. Now I have to calculate these parity bits, p1, p2, p4, that we have to calculate this. Up till now we have just formed the Hamming structure from given data. Now let's start calculation of these parity bits. So as I told you, if I have to calculate the value of p1, how can I calculate? Check 1, skip 1, check 1, skip 1, check 1, skip 1, check 1, likewise. So what should I consider over here? P1, D3, D5 and D7. Okay, now value of P1 we have to calculate, so leave it. But we have a value of D3, D5 and D7. D3 is 0, D5 is 1 and D7 is 1. Okay, so 0, 1, 1. How many ones are there? These are the 2 ones. Okay, it means that even value. And if the value is even, the parity bit is 0. And if it is odd, number of ones are odd, then the value of parity bit is 1. See here, next one, P2. P2 ला काय काय कन्सिडर करणार मी? P2, D3, then P4, D5 skip केला, D6, D7. ठीक है, so P2 we have to calculate, leave it. So D3 we are having 0, D6 0, D7 is 1. How many ones are there? 1 means odd. Odd असेल तर parity bit is 1. Okay, and last one, P4. P4, for P4 we have to consider P4, D5, D6 and D7. P4 leave it, D5, D6, D7 101. So it is even, so value of P4 will be 0. Now we are having the data, we are having the parity bits, just put the values. So after putting the values of P1, P2 and P4, I'll get this whole Hamming code structure. P1 is 0, whatever we have calculated here. P1 ची value इथे 0 आहे. P2 is 1. Okay, and P4 is 0. And remaining data bits already we are have. Clear? समजलं इथपर्यंत? स्ट्रक्चर कसं आलं, हॅमिंग कोड कम्प्लीट कोड कसा मिळाला समजलं का?
Yes, ma'am.
Everyone, there is no doubt.
Yes, ma'am.
No, सगळं समजलंय. हा, yes, okay, most of you have understood. Good one. Okay, okay, fine. So you have understood it. Now आता इथपर्यंत काय झालं बघा आपलं. Up to this we got only message. फक्त हॅमिंग कोडचं स्ट्रक्चर मिळालं. नाव व्हॉट वी हॅव टू डू, वी हॅव टू check the error, and if error is there we have to detect that error and as well as correct the error. ठीक है. So how to check this error and how to correct that error we will see. Yeah, after this we have seen. Now we will address for error detection and correction in the hemming code. So after hemming code, data is transmitted. It is decoded at the receiver end to get the original data. Okay, it is decoded at the uh, receiver side to get the original data. So this is your data and it is decoded. Now to detect the error at the receiver side, what procedure is applied is this one, detection of the error. Okay, so at the receiver side the bits, that is nothing but the position, the bits 1357, 2367 and 4567 are checked for even parity. ओके, रिसिव्हर साईडला काय केलं जातं, सो दीज बिट्स हे जे आहेत कॉम्बिनेशन, दीज आर फिक्स्ड, यू हॅव टू रिमेंबर दिस, हे विसरायचे नाहीत. हे जे कॉम्बिनेशन्स आहेत these are fixed, only these are checked at the receiver side. Okay, so check 1357, 2367 and 4567 हे कशासाठी चेक केले जातील, तर पॅरिटी बिट साठी P1, P2 and P4. Okay, for P1 check 1357, for P2 check 2367 and for P4 check 4567 for even parity. ओके, इवन पॅरिटी आहे का नाही ते चेक करायचं, म्हणजे आन्सर नंबर ऑफ वन्स किती येतात, इवन ऑड आहे. ठीक आहे, इवन असतील तर काय आणि ऑड असेल तर बट किट फॉर द इवन पॅरिटी or for bit groups mentioned above possess the even parity, then a received code word is correct. ठीक आहे, सो ह्या सगळ्या कॉम्बिनेशनचा इवन पॅरिटी आलं. सो कन्क्लुजन what data is received that is correct, there is no error. And if parity is odd for any group, कुठल्या पण एका ग्रुपला जर ऑड पॅरिटी आली, then there is an error. Am I clear? So if I check this, it comes even, it also comes even, and it also comes even, then it means that there is no error. But any one combination, suppose 4 5 6 7, it is coming as the odd, so it means that there is an error. Okay, and it has to correct. Okay, now suppose error is not there, then it is okay that we can finalize the code that the received data is correct. But what if the error is there, एखादा बिट माझा ऑड आलाय, एखादा ग्रुप वरचा जो चेक करते मी, if any one group comes as a odd, means that there is an error. Now if error is there, then how to correct that error? So these are the steps. Okay, how to correct. Now suppose an error is located, an error is located by framing 3-bit number out of 3 parity checks. Okay, so we are having 3 parities, P1, P2 and P4. Sorry, P4 is there. So from this we can calculate the error. So how to calculate? We write the error word as below and then find the value of parity bits. So P1, P2 and P3. It is written like this. Value of P1, P2 and P3 we are already having. Okay, now after doing all this procedure, suppose, sorry, here I have not mentioned. Okay, I'll just read it at the time of example, you will get understood. Okay, so check the parity of P1, D3, D5 and D7. If it is odd, parity error exists. Hence, we write P1 is equals to 1. But if it is even parity, no error, P1 is equals to 0. So whatever procedure I have explained above, that is written over here. Similarly, find for P2 and P3 also. After finding all the values of P1 and P3, what we have to do, find decimal value of it. ओके, याचे काय करायचे, डेसिमल व्हॅल्यू फाइंड आउट करायची. कशी करायची सांगते. डेसिमल जे तुमच्या व्हॅल्यू झालेले आहेत P1, P2 आणि P3च्या अकॉर्डिंगली डेसिमल व्हॅल्यू फाइंड आउट करायची. अँड आफ्टर गेटिंग दिस डेसिमल व्हॅल्यू, that decimal value will be the position of that error. Suppose माझी decimal value आली 5. So I can conclude that at 5th position the error exists. Okay, now how to correct? Just invert the bit, your error will be corrected. Suppose 5th position ला 0 आहे, means what, error आलेली म्हणजे काय असणार आहे, ऑब्विसली 1 चा 0 और 0 चा 1 एवढाच काय तो चेंज असणार आहे. सो 5th पोझिशनला एरर आहे म्हणजे काय झाला, 0 चा मला 1 केला पाहिजे. सो इफ आय चेंज दॅट बिट, इन्व्हर्ट दॅट बिट, माय code will be the correct code. Simple. Okay, so this is total Hamming code, how to detect and correct. So in same example I'll explain the correction of error, this one. So up to this we have calculated the Hamming structure. Now suppose in this example they have given that, okay, they have given that suppose while transmitting an error, while transmitting the data, error occurs at 7th bit. Okay, error occurs at 7th bit. So explain how will you detect and correct the error. 7th bit ला error occur होते हे consider करायचंय आणि कशी करायचं. वन सेकंड, याच्यापेक्षा एक सिंपल एक्झाम्पल आहे, this one, correcting of the errors. Yeah, this one, this is most easy. Okay, so we'll see this example for correction of the error. Okay, so here also we are having the 7-bit Hamming code, and assume even parity and state whether received code word is correct or wrong. If wrong, locate the bit error. Now याच्यावरून काय करायचं, आपल्याला चेक करायचंय की ह्या हॅमिंग कोड मध्ये एरर आहे का नाही हे चेक करायचंय. ओके, सो हाऊ टू डिटेक्ट द एरर. सो फर्स्ट स्टेप काय सांगितली होती, we have to check these groups 1 3 5 7 2 3 6 7 and 4 5 6 7 for P1, P2 and D4. So first check these groups. Okay, so check it. So for P1 check 1 3 5 7. Okay, so 1 3 5 7, P1 is equals to 1 3 5 7. 1 ला काय 1 आहे, 3 ला 0, then 1 and then 1. So number of ones are 3, that is odd. Means odd आहे म्हणजे काय, error exist, because number of ones जर even असतील it means that there is no error. ठीक आहे, so one bit is having error, still we'll check others also. So for P2 we have to check 2 3 6 7, then number of ones are 2, it is even, so P2 is error free, so because P2 is 0. P4 check 4 5 6 7, so number of ones are 3, so it is that error exists. So clearly P1 and P4, these two are having the errors, means there is some error exist, we have to correct it. Now how to correct this error, correcting the error, see here, write error word and substitute values of P1, P2 and P4. Okay, P1, P2 and P4. ह्या values कोणत्या आहेत, P1, P2, P4, not the parity values, whatever we have calculated here, that we have to consider. What is the value of P1? It is 1, P2 0 and P4 1. So see, 1 0 1, P1 is 1, P2 is 0, P4 is 1. So I have kept this value. Now, after keeping this, we have to calculate the decimal value of above number to calculate bit error. How to calculate the decimal value? So, yeah, 2 raised to 1. P4 ची value काय आहे? It is first position. Huh? So, for 2 raised to this 1, it is equals to 2. Then 2 raised to this 0, it is equals to 1. And 2 raised to again 1, it is equals to 2. Powers म्हणजे काय असणार आहेत? Value of parities. Okay, so I'll get 2 plus 1 plus 2 is equals to 5. So this 5 is nothing but at fifth position there is an error. Okay, at fifth position there is an error. Now check whether the error is there. Okay, so this is our code word or 7-bit. So first, second, third, fourth and fifth. Okay, it means that this fifth position contains an error. Now how to correct? Just invert the bit. So this 1 I have inverted as a 0 and my final data will be this one 1001188. समजलं? Yes, are you getting?
Yes, ma'am.
Each and every step कळलेली आहे हॅमिंग कोडची. Is there anyone is having any problem? Please let me know. Yes, आहे का काही प्रॉब्लेम? Yes,
Hello, ma'am.
anybody is having any problem? Ah, yes. Yes, Amruta.
Can you repeat? Can you repeat this part?
Yes, yes. Which part? म्हणजे कुठून समजलेलं नाही तेवढं मला समजू दे. मीन्स आय कॅन रिपीट. सगळं पूर्ण समजवायचंय. Yes, Amruta.
Hello, ma'am.
Which part you don't understood?
Example.
Yes. Okay, example. Okay, so I will explain again. First, let me know whether you understood, means all of you, huh? Whether all of you have understood how to generate this, how to construct the Hamming code. Whatever I have earlier in earlier example, how to construct this Hamming code. Have you understood how to construct it? Suppose 4 अंडरस्टूड ओके सो 4-bit डेटा दिलेला असेल तर मला पॅरिटी बिट्स कशा काढायच्या हे समजलेलं आहे. पॅरिटी बिट्स कशा असणार आहेत सर इवन असेल तर 0 ऑड असेल तर 1. That way we can calculate the values of the parity bits and we will have a total Hamming code. Okay, so it's easy. No need to explain it again. Okay, now the most concern part that we have to see is that how to check the error and how to correct that error, that we have to see. So the first step to check whether your Hamming code contains any error or not is that we have to check certain combinations or certain groups we have to check for the given data. So what are these groups that are fixed? हे ग्रुप्स काय असणार आहे तुमचे फिक्स असणार आहेत. What are these groups? 1357 for P1, 2367 for P2 and for P4 4567. These 3 groups we have to check for even parity. Even parity means what? Number of ones किती आहेत त्याचे चेक करायचे. And if suppose all these 3 groups contains an even values, it means that there is no error. Okay, and if any group contains odd parity, it means that some error contains. Okay, there is an error. Now let's check. So we are having the one second. We are having the this particular Hamming code. 7-bit Hamming code is there. From this, we have to first detect the error. So as I told you, check the groups for P1, P2, and P4. So for P1, we are checking the values of 1, 3, 5, 7 position. So P1 is what? This 1. P3, 3 is what? This 0. 5 is what? 1. And 7 is 1. So what is the value? 1011. So this is the combination. Now number of ones are 3. Means what? It is odd value. Na? 3 is odd. So if odd, the value is 1. ओके. याच्या आधी पण आपण तेच केलेलं आहे. P1 ची व्हॅल्यू काढताना, P2 ची व्हॅल्यू काढताना ऍक्च्युअल मध्ये. सिमिलरली इथं पण तेच करायचंय. फक्त ऑड आहे का इव्हन आहे ते चेक करायचं. आणि इव्हन असेल सगळ्या व्हॅल्यूज, एरर नाही. एक जरी व्हॅल्यू ऑड आली, एरर आहे. सो हिअर फर्स्ट इट सेल्फ व्हॅल्यू कंटेन्स अन एरर P1. It is 1. Means error exists. Again calculate for the P2 also. P2 we have to consider 2367. ठीक है. So 2367, it is 1001. Number of ones are what? It is 2. So it is even. So it is error free. Okay. Then P4, for P4 we have to check 4, 5, 6, 7. Number of ones are 3. That is odd value. Means error exists. So from this we can conclude that yes, there is an error. Error ahe. But where is the error and how to correct it? Now for that, how to check where, means which bit contains an error? So this one is the procedure. So for this we are writing the values at P1, P2 and P4. Okay. So P1 ची value already आपण calculate केलेले. These value we have to consider, not the earlier one. This one for error checking. So what is the value of P1? It is 1. P2 is 0. P4 is 1. So check it. So I have just kept the values 1, 0, 1. So after keeping these values of P1 and P2, we have to calculate the decimal value. Decimal value of what? These parity bits. Okay. Now 2 P4 चा parity bit काय आहे? 1 आहे. So 2 raised to 1 is equals to 2. ठीक आहे. Then P2 ची काय व्हॅल्यू? 0 आहे. So 2 raised to 0 is equals to 1. Then P1 ची व्हॅल्यू P1 ची व्हॅल्यू काय आहे? 1 आहे. So 2 raised to 1 is equals to just the values, these 1 and 2 is equals to 5. So what is the conclusion? So fifth bit contains an error. Okay. So up till now we have got the conclusion that error exists. Also we understood that fifth bit contains an error. Up to this we know. Now how to correct? So correction करायचं असतं म्हणजे काय असतं? Only we have to check or we have to revert 1च 0, 0च 1. So check the fifth bit. What is the fifth bit? It is 1. In Hamming code, हा कुठला आहे डेटा? This one. Original data. This one. 10111011. What is the fifth bit? It is 1. So correction of the error means just invert it. So 1 will become as a 0. So my data will be 1001011. That will be my data. Finish. It is easy. Only we have to check what should be the next step. हे फक्त लक्षात ठेवायचं. So if you got the flow of calculating the error, parity bits, then positions, then nothing is difficult in the Hamming code structure. Only theory is too much. So from that maybe we got to conclude that yeah, it is quite difficult. ठीक है? Are you clear now, everyone? Yes,
Yes, ma'am.
नक्की समजलेलं आहे का? Because you have to solve the example, huh?
Yes, ma'am.
If you don't understood anyone has don't understood, please let me know. I hope it is clear now. Hmm? Detect and correct the error. Okay. So the second example, just this data. So I'm going to share the PDF today. So you have to solve this example, huh? 1001101. That will be the data for you. Today's homework. 1001101. ठीक आहे. याच्यावरून काय करायचं? You have to. This is 3, 4, 5, 6, 7. This is total Hamming code. No need to calculate the parity bits. Parity bits calculate करायची गरज नाही. Directly take this as a structure, okay, or Hamming code structure. Check whether error exists or not, and if error exists, at which position it is exists. So that you have to calculate. Okay. So आता जे हे example आपण solve केलेलं आहे, similarly you have to solve this example. Also I'll post some examples like this also, this one, but I have to correct this example, that's why I have not explained now. So I will send you the corrected PDF for this one today itself. ठीक है. Any problem? Anybody is having any problem up to this? So your next example is what? 1001101. So that will be your data. होईल सॉल्व everyone? होईल का सॉल्व?
Yes,
Yes
ma'am.
or no? Yes. Okay. So this is the Hamming code. Okay, fine. So we'll stop here because you are having one session. Before that, I have to give you the break.